Today I'm going to explain question 1. For the question 1, we have given a circuit diagram that we have to follow, but without the value of each component. So we have chosen for the inductor will be 100 millihenry, for the capacitor will be 40 microfarad, and for the resistor will be vary through each cases. For the resistor, over them will be 2 ohm resistor. For the critically damped will be 35 ohm resistor. For the underdamped will be 30 ohm resistor. Each cases have different equation, such as for the overdamped, the alpha will be higher than the omega. So with this resistor, it would make the circuit cases to become an overdamped circuit. Same goes as this, but for the critically damped will be the alpha and the omega will be same value. Same goes as for the underdamped. The alpha will go lesser than omega. But with the resistor, the help of the resistor value, it will make the circuit to go underdamped case. For the current source will be synchronized. That will be 8 ampere for each circuit. As you can see here, with different value of resistor, we change how the waveform would be look. Like here, this is a overdamped waveform with the highest is the voltage and the lowest is the current. For the critically damped, you can see here, the green line indicates the voltage and the red line indicates the current. For the underdamped, also same. For the green line indicates the voltage and the red line indicates the current. As you can see here, this is the different circuit current. For the blue line will be the underdamped. For the red line will be the critically damped, and the lowest one, the green line, will be the overdamped. This is the current graph. And for the voltage graph, overall voltage graph, you can see the difference between three cases. The lowest one will be the overdamped. The middle one will be the critically damped, and the highest one will be the underdamped. That's all for me. I'm passing it to the next presenter. Thank you.
If you look at my screen, this is the circuit of the question 2. I want to make the simulation of my question 2, so I need to construct the circuit of my question 2. And if you look at this circuit, I already put the information given in question 2, which is the resistor, inductor, capacitor, and also the voltage source, which is I already put 20, the question given, and the frequency, we need to find the frequency, which is use the omega ohm, and we get the time, and 1 over time, so we got the frequency. And also our current source, also I already put the 10 ampere in the current source. If you look this, and this simulation is we want to get the current IA, current IB, and current IC, and the voltage VT. So we need to construct this circuit to get the current and the voltage, and we drag the port to the our analog analysis, which is this thing, and we drag the voltage IA, IB, and IC, so you can see the steady state of the response in this frequency. And if you look at the detail, you can see the different with the voltage IA, IB, and IC. So the green one is the voltage, and the red one is IA, and blue one is IB, and of course the yellow one is IC. So this is the steady state of these three components we need to simulate. And also if we run this circuit, we can get the answer of the IA, IB, and IC. So let's go. It's normal to be this value of IA, IB, IC, and VT is not stop or anything because we use the AC voltage. So we just need to stop the simulation, and we know that answer of IA, which is 0.018, and IB is 0.0086, and IC is 0.41 at 01, and the voltage is V equals to 0.2249. So we already get the three answer of this thing, and we compare the answer of our simulation in the manual calculation, and we know that our manual calculation is it correct or not, and also the simulation, is it correct or not if we get the different answer of IA, IB, IC, and VT. So this the simulation of question 2. We go back to our waveform. This waveform, we need to edit the graph, which is the Y scale 1.5 of the negative, and maximum value is 2. So if we put the larger value of this, we can get the larger of the frequency. Like example, this thing, I change the maximum value is 10, and our stop time is 100 milliwatt. So this the graph of after we change the y-axis and x-axis, and we cannot see the difference of VT, IA, IB, and C. If we need to see it more detail, we just change the stop time to 1, and the Y scale to the small value, so we get the answer of the difference in the circuit. And we also can use the mouse to see it more larger and more detailed. So this is the difference of VT, IB, and IC. That's all for the question 2. I hope you learned something new in this question 2. Thank you. That's all for me.